This video will cover changes in internal energy or enthalpy for a phase change. So an example of this from everyday life is boiling a pot of water to make some pasta. So it requires a lot of energy in order to do this. So a really neat problem that I sometimes give for homework is calculating how much it would cost you in energy to make a bowl of macaroni and cheese. So for a known volume of water, you could calculate the mass of water. Then by knowing what the how much energy is required to transform that water from the liquid phase to the vapor phase, you can calculate how much energy is required. So this is a very simple section for phase changes. These things are usually tabulated, and the quantities that you'll want to commit to memory is the heat of vaporization. This is a bit of poor terminology in my opinion, because heat means Q, and yet this is something a little bit more specific. So this is also sometimes called the latent heat of vaporization. So just note that out front. Latent heat of vaporization or enthalpy of vaporization is another term. Enthalpy of vaporization you might also hear. This quantity is literally the energy that is required to transform a mole, if it's the molar quantity of a substance, from the liquid phase to the vapor phase. Going from liquid phase to vapor phase. And therefore, if you wanted to go the other way, if you wanted to go from the vapor phase to the liquid phase, then you would need to know the heat of condensation. However, the heat of condensation is not oftentimes tabulated because it is simply the negative of the heat of vaporization. Before I discuss that further, I just want to make a note that we have seen the heat of vaporization before. Remember, in the Clausius-Clapeyron equation, we use this term. This delta H hat sub V is the enthalpy of vaporization, or the heat of vaporization. So I just wrote down what I was just talking about, that enthalpy is a state property, and therefore the forward process and the reverse process can be treated as such. So the heat of vaporization can be also known as the negative of the heat of condensation. So let's say, for example, a substance has a heat of vaporization of 40 kilojoules per mole. That would mean that the process of going from liquid to vapor requires a change of 40 kilojoules per mole, whereas the opposite would be negative 40 kilojoules per mole. The other term that you'll need to know is the process of going from solid to liquid. That is called the heat of melting. And similar to the heat of vaporization, you can also have a heat of solidification, which would be the opposite. You could also have enthalpies for the other phase changes. So you could have the heat of sublimation as well. We won't see that as much in this course, but just be aware that that can occur. Okay, so the two main terms that you'll have to use and look up in the case of phase change operations are going to be delta H hat V and delta H hat M. I've just described in which processes you would use those for. And like I said, for the opposite process, you would just use the negative of that value. These can both be found in table B1. B.1. And the only thing to be aware of is that these enthalpies of vaporization and enthalpies of melting that are tabulated are for the normal boiling and melting points. Beware. The tabulated values in the back of the book, or if you look at these on the internet, right, you have to be aware of when you see these are functions of temperature and pressure, right? At a different pressure, water, for example, is going to boil at a different temperature, and therefore the enthalpy of vaporization and enthalpy of melting will be different. The tabulated values are for the normal boiling / melting T. And this corresponds to if pressure is equal to 1 atmosphere. If you have a higher pressure and your temperature, the boiling point temperature, the melting point temperature is different than the normal boiling point temperature, which will be the case if pressure is different, then you have to construct a hypothetical process path. And we'll cover that in a coming class. So that's all for this video. In the final video, I will show you exactly where to find these values in the back of the book, and I'll also discuss those tables in a bit more detail.